Namaskar. Today I am going to start a new topic that is corrosion. Actually, to see this topic, the first question arises in our mind that what is corrosion? The answer will be corrosion is a gradual degradation. Corrosion is a gradual degradation of metal by chemical or electrochemical reaction with its environment. Okay, so then what is the definition? The definition is corrosion is a gradual degradation of metal by chemical or electrochemical reactions with its environment. Okay, so then there are a number of examples that we can see, like rusting of iron. Actually, it is a common example, that is rusting of iron. And not only this, we have other examples like formation of greenish film on the surface of copper metal. This is another example of corrosion. Actually, in copper metal, copper oxide and copper carbonate forms a greenish film on the surface of copper metal. And then another example, you can see rusting of silver and silver converts into black color due to the formation of its oxide. So then it is corrosion and their examples. Now we are going to discuss about theory of corrosion. So then theory of corrosion. Okay, actually there are two theories. Which can be easily explain the entire process of corrosion, which are number one chemical corrosion or dry corrosion. and number 2 is electrochemical or wet corrosion. Okay, we are first discussing about chemical corrosion or dry corrosion. It occurs in absence of moisture or any solvent. So the important point is chemical corrosion occurs when moisture and any solvent are absent. Then chemical corrosion can further classified into 3 categories, like A, B and C. Then A is oxidative corrosion. B is other gases corrosion, and C is liquid metal corrosion. So then there are 3 categories: oxidative corrosion, other gases corrosion, and liquid metal corrosion. Then first we are going to discuss about oxidative corrosion. A, oxidative corrosion. In this corrosion, metal react with metal react with atmospheric oxygen and gets converted into its oxide. In this corrosion, metal first oxidize into metal ion and electrons are released. So then this is metal and this is metal ion. Okay. These electrons are accepted by atmospheric oxygen and converts into oxide ion. So and we can write atmospheric oxygen and electrons. Here we need 2 electrons, then 2 Ne, and oxygen gets converted into 2 oxygen metal ion. Okay, then overall reaction will be, here we can see here is 2 electrons, 2 Ne, and here is only Ne, so we can here multiply it by 2, so then this one and this portion is cancelled, and 2m plus O2, and if we add metal and an oxygen ion, then we will get MO, and this is metal oxide. Metal oxide. Okay. Thus, this is the oxidative corrosion. The second type of corrosion is other gases corrosion. Other gases corrosion. As we know, not only oxygen, there are other gases have corrosive properties present in atmosphere. Then, if corrosion takes place rather than oxygen, it is considered as other gases corrosion. Like carbon dioxide, S2S, and halogens, SO2, Cl2, and other gases have corrosive property. So all these gases are considered as other gases corrosion if they are create corrosion. Okay. The next type is liquid metal corrosion, and C is liquid metal corrosion. In this type of corrosion, some anhydrous metals show their corrosive effect when flow in their carrier tubes. The well-known example of anhydrous sodium metal. Anhydrous sodium metal, when it flow in carrier tube, it creates corrosion in inner wall of carrier tubes. Actually sodium metal is used as coolant in nuclear reactor. Okay, then there are 3 types of dry or chemical corrosion, and I hope everyone is clear about dry corrosion. And the next theory is electrochemical corrosion or wet corrosion. Then first of all, what are the necessary conditions for this type of corrosion? Then conditions are, number one is metal must be in contact with moist air or any solvent. Or the second condition is two different metals are present in common solvent. So these are two necessary conditions. If these two necessary conditions are fulfilled, then electrochemical corrosion takes place. The first one is metal must be in contact with moist air or any solvent, and second one is two different metals are present in common solvent. Okay, it means in this type of corrosion, moisture or solvent plays an important role. Actually, in wet corrosion, when metal is in contact with moist air or solvent, there are two different areas are formed. One is anodic area, where anodic reaction takes place, and second one is cathodic area, where cathodic reaction takes place. It means electrochemical reaction, electrochemical corrosion or wet corrosion composed of two types of reactions, that is anodic reactions and cathodic reaction. Anodic reactions. A number. Anodic reaction. Anodic reaction always oxidation of metal into metal ion. Okay, so then it means M is for metal, M is on oxidation converts into metal ion and electrons, like this. Then you can see metal is converted into metal ion. Actually, the area or portion where anodic reaction takes place is called anodic area. Okay, and anodic area always suffer with corrosion. Means corrosion occurs only at anodic area. This. Okay. Then in anodic reaction, there is only one reaction. Metal is converted into metal ion and electrons. Okay. And then second, B is a cathodic reaction. B is a cathodic reaction. Okay. In cathodic reaction, electrons are consumed. These electrons are consumed in cathodic reactions, which are released at anodic reaction. Okay. Actually, the nature of cathodic reaction depends upon oxygen